Hi there, so we've already covered numbers and number methods. Now let's come on to one of the very important concepts that involves numbers, and it's called the math object. So the JavaScript math object allows you to perform mathematical tasks on your numbers. There are many common tasks that you will want to perform, and math object gives you the right set of methods that you can use to perform these operations. So let's see a very good example and a simple one. It might happen that you might want to use certain common elements during your mathematical computation, and math object provides you with that. So let's see a very basic example. And the first thing that comes to mind to any formula is the pi value. And pi, again, it's difficult because some people write 3.14, some people write 3.147, and so on and so forth, or 22 by 7, for example. To standardize that, you can use something called as a console.log, and let's do a math, which is the math object I'm talking about, and in uppercase pi. Again, it's uppercase pi because it's a constant. Pi value is, and let's do this. Okay, let's close the outputs. Let's open the input console and then see. The value is this. So every time you use the math.py, you are certain that your equation will always have the constant result or probably the same behavior. Just like math.py, there is a very fantastic rounding off. Usually what happens is sometimes you need to round off certain numbers so that you can perform more actions on them depending on what the value is, if it is less than versus greater than. So what you do, so let's see an example. Let's say 4.7 rounded off will be, and then you can use the function or the method round, and let's pass the parameters 4.7. Let's try to run this, and the answer would be 5 because it will round it off to the nearest integer. Now what if it were 4.4, for instance? 4.4. Let's run it, and the answer would be 4 because it's less than 4.5. Similarly, there is a very fantastic method which is called power. So usually you might have to raise certain elements, let's say 2 square, 2 cube, 2 raised to 4, and so on and so forth. In that scenario, you can use power. So POW of 2 raised to, let's say, 3, so that it's 2 cube. In that case, it will accept 2 parameters. Let's change this to POW because that's for power. It will accept 2 parameters, 2, 3, because you need the cube or raised to power of 3. The first is the number and the second is the power. Let's run it, and the answer should be 8. You saw that, and then this gives you the power to raise it to anything. So if I want, I can also have the same thing, which I can do a square. So let's say 8 square, for example, 8 raised to the power of 2. In that case, this becomes 8, this becomes 2. Let's clear the console, let's run it, and the answer is 64 because that's 8 square. Now what if you want to do a square root, because we were able to do the square very easily. So yes, to our rescue, there is something called as a square root method which is available for the math object. Let's try to put that, which is SQRT of, let's say in our case, we can just do the same, revert the same example, which is 8 square was 64. Let's do square root of 64 and SQRT of 64. Let's clear the console, run it, and the answer should be 8. So you raise it to the power 2, you get 64, you square root it, you get 8. The other very common method that we have from math object is the absolute value, which is ABS of a certain value, and that's usually used when you have a negative and a decimal number, let's say minus 4.7, and you just don't need the negative part of it or a positive. You don't know, you just need the integer or a number part of it, and in that case you just give an absolute and you give minus 4.7. In this scenario, it should return you 4.7. Absolute value just removes the positive negative sign and gives you the value. We already saw the power of rounding, which is 4.7 becomes 5 and 4.4 becomes 4. But what if you want to control how the behavior is? Let's say by default you want everything to be on the upper side, which means, let's say even if you have a 4.2, you want it to be 5. So let's do the same example, 4.4 of 4.4. Let's do 4.4 and let's do a seal. So if you would have done a round, the answer would be 4. But as we said, a ceiling, which means the upper value, it takes the value of 5. Similar to the ceiling, we have something called as a floor, as you would expect. What floor would do is, irrespective of the value is, even if it's 4.9, it will take the value to the nearest integer, which is lower. So let's say 4.9. Let's run the same example. In this scenario, it goes to 4. So seal and floor are very useful when you are computing or doing mathematical operation and doing a division and you want the lowest or the highest number. So that's where it comes into picture. Now, what is JavaScript without the trigonometry? Well, yes, the math object has you covered there as well. If you remember your trigonometry classes, you had something called as sine, cos, tan, cosec, I think sec, and cotan, I think. Well, yeah, those were the trigonometric waves that we have, and probably it was used in many computations too. The math object also has you covered there, where you can use something called as a math.sin, which is sin, to get the value of sine, and math.cos to get the cos value of something. So let's see them in example. And again, sine and cos waves are usually in the range of -1 to 1. So the value of them would be -1 to 1. And the way you make it work is math. Let's do a console log first. And then do a math.sin. And let's put this in the code so that we know that what value we are checking for. And then the value math.sin. Now, what do you expect would be the input or the parameter for math.sin? It has to be an angle, because you do a sine of a particular angle. So you can have angles in radians, or you can have it in degrees. But math.sin accepts it in radians. So always in radians. Now, if you want to convert this to let's say degrees, there is a formula that we use in mathematics, which was angle in radians is equals to angle in degrees into pi by 180. So you can use this to get the angles in radians if in case you want to, give the angles in degrees. So let's see that in our use, and let's do a sine of 90-degree angle. So in this case, it would be 90, using this formula, angle in degrees 90 into pi. We just saw how to get pi, which is math.pi divided by 180. Let's clear the console and let's run. So the answer is 1, because sine of 90 is 1. And similarly, let's say cos of 0 is 1. So let's do a cos, but 0, we don't have 0. So let's just do a 0 degrees and put it into radians. And let's clear this. Let's run, and the cos is 1. So that was math, sine and cos. Let's see another example or another method that we have in the math object, and it's called math.min of a set of numbers and math.max of a set of numbers. So usually you might have to get the minimum or a maximum for a range of numbers. You can use math of min and max. Let's put that to use. So math.min example, and let's put the quotes. Let's do a math.min and pass the numbers. Let's say 2, 4, 6, 5, 1. Very basic example. Let's close the console log and let's see what happens. The minimum is 1. You can see this here. What if I make this 5 as a -5? In this scenario, the answer should get converted to a -5. You can see this. Just like this, we also have a math.max, and the answer here should be 6 because that's the maximum that you have. Let's say instead of 6 I make this a 14. In this scenario the answer would be 14. So you can definitely get minimum and maximum for from a particular set. You can pass in any number of arguments to the math.min and math.max. Just like math.min, math.max, there is another very cool method that we have in mathObject, which is called math.random. And this is very useful when you're writing any random procedures. So I will tell you one very good example where I used it. It was when I wanted to automate some kind of a post onto my system, but I did not want it to be timed exactly the same. So I used a random number between 15 minutes to 30 minutes where it will post it. Let's just see what math.random can do for us. So again, math.random returns a random number between 0 and 1. So you can expect any number which is 0 and 1. And let's try to do console.log math.random. Let's do it 3 times so we see that every time we call it, we get 3 different numbers. Let's do a plus, space, plus. Let's copy this once more. Let's close the bracket. Let's see what the numbers are. So you can see it's 0.599 whatever, 623 whatever, 239 whatever. So you always get a new number whenever you use math.random. So we already talked about math.py, which was one of the properties or a constant that we used. Now what are the other properties that we have for mathObject? Well, let me tell you that we have something called as a math.e. What it does is it gives you the Euler's number. So just like pi, if you need to use e, you can use that. And of course the next one is math.py, which would give you the value of pi. Similarly, you have math.square root. What this does is it gives you the square root of 2 by default. So just like you can compute the power and the square root of many things, by default if you want a square root of 2, you can use this. Similarly, you have math dot square root of half, which is 1 underscore 2, the way we denote it is, and it's nothing but square root of half. Let's see the next one, which is math dot ln2. ln2 basically stands for natural logarithm of 2, which means log of 2. So you can expect log of 2 when you use ln2. Similarly, you have a math.ln of 10, which means you have log of 10. We also have math.log 2e. What does this mean? This means log of e to the base of 2. Log of e to the base 2. Similarly, you have math.log of 10e, as you expect, because that means it's log of e to the base of 10. So these are all the properties and the constants you will need from the mathObject. Now we already saw, just like we have numbers as an object, unlike other global objects, mathObject has no constructor. So you cannot have something called as a variable x is equal to, let's say you had for number as new 10. You cannot have something like that for a mathObject. You cannot definitely create a mathObject like that. But methods and properties are static, which means they can be used but they cannot be changed. They are just initialized once and they can be used forever. All methods and properties can be used without actually, creating a mathObject first. You can directly do a math of something and then you can use it. And there are more methods for the mathObject that you can use other than the absolute, ceiling, round that we saw. We also have tan, we have log, we have a cos, a sin. I think there's a whole big list that's available. I will share you the reference for the mathObject that you can use. Go over, play around with it, and let me know if you have any questions. Thank you.